Hello and welcome to OH3SPN. Now, yesterday I recorded a video which was meant to be a short 10-minute video which turned into a 40-minute discussion. The subject is antennas, specifically antennas for newly licensed foundation holder licensees, perhaps people that don't have the wealth of knowledge that those that have been in the hobby for years or decades have. And to try and cover a lot of the mistakes that people make, the reason why people struggle and have difficulty and maybe come away with the wrong impressions about power levels that are needed, or the hobby as a whole. I mean, it all essentially comes down to antennas, and this is perhaps one of the most confusing subjects really for someone new to the hobby. You go out, you buy your radio, perhaps your high-end radio. You have a 5 or 10 watt, perhaps, limit, and you struggle to be heard. And it does provide this impression that in order to do anything in the hobby, you need 100 watts, you need 500 watts, you need beams, and really it's... How can I put it? Antennas, if you're starting out, simplicity normally results in efficiency. The more compromises you have in an antenna, the less efficient, generally speaking, you can expect it to be. So most of the marketing and most of the antennas that are aimed at newbies are attractive because they cover multiple bands. They're easy to erect. These are two, perhaps, major compromises in terms of performance. So I'm re-recording this, and I'll try to keep this really basic. And I'm maybe oversimplifying things, but I don't want to get into this 40-minute discussion again when the point I'm trying to make is quite simple. So most antennas are either some form of dipole or vertical. Now, if you have a radio here with our VFO, let's say, for simplicity, and again, if you're new to the hobby, coax is easy, ladder line is somewhat baffling, so we won't cover ladder line for now. But you have your radio, you have your coax up to, let's say it's a dipole, so you have a balun here. It's important to have a balun here, and I'll go into why in a minute. But your dipole is then balanced. So you have an unbalanced bit of coax, which is basically the outer is a shield at DC ground. The center is the signal. What the balun does is it's basically a transformer, which takes that unbalanced, the single conductor, which is essentially live, if you think of it that way, and it puts it creates a balanced output. Now, what do we mean by a balanced output? What we mean is that both of these, if the center is connected up to here, imagine this, then you have RF doing a waveform, something like this. Now, if you don't have a balun, then theoretically the outer part of the coax is connected to this, but the outer is the shield. So, I mean, this shouldn't be doing anything. But what actually happens, because of the inductive coupling with the main element, you do get this. It's just how the antenna works. So the problem then is without the balun is that this is connected directly to the outer, so you get all the RF flowing back through the outside shield of the coax, common mode we call it. So this is not ideal for many, many reasons. First of all, you get loads of RFI, you get more interference, plus it changes your radiation pattern because this part of the coax starts acting as part of the antenna. Not good. And I must say, I'll just very quickly, this interference, when you're transmitting, this interference may interfere with your computer. Maybe your sound card will drop off. If you're doing data modes, the radio will disappear from the computer. If you've got speakers, you might get buzzing, which is not so great. But the thing people forget is even if you chase down some of these problems with putting ferrites everywhere on all the cables, it's a two-way thing. So you transmit, it causes problems on your computer or hi-fi or whatever you want. Most things, infrared lights, security lights. These things also increase your noise floor. If this isn't decoupled from the antenna, if the outer is picking up noise, then your noise floor will increase. So, you might have like an S3 background noise where you can't hear anything below S3. Fit a balun and you'll find it will drop to S1 or below. So, baluns are important. And of course, talking about the transformer, you have the unbalanced signal with just the live, I keep saying live, it's the wrong word, but you have the signal on the center conductor. The transformer basically transforms that into a balanced signal so that both of these parts of the antenna are doing what they should be doing. That's equal and opposite. So when this point on this antenna is at a low, on this element is at a low, on this element it will be high. So they're equal and opposite. Now, one of the antennas that are really popular at the moment for newcomers to the hobby is, let's see if I can, in fact it's probably easier for me to just to do that. We have this, which is an off-center-fed dipole. This offers multiple bands, which seems quite attractive because it's easy, you can string it up, there's nothing too difficult to it. The problem is because it's purposely unbalanced, even with a balun here, there's a high likelihood that we'll get RF coming down here. And more often than not, when you see people online saying, I've just bought a new antenna, my computer's not working properly, the radio's disappearing from the USB bus every time I transmit, it's an off-center-fed. Well, it's either an off-center-fed dipole, or it's a long wire with a balun, or not really a balun, I guess it's an unun here. And, you may have a triangular looking tree, and you throw your wire up into the tree, and yeah, this is an impedance matcher, basically. It transforms, you have 50 ohm coax here, you have some high impedance here, it transforms it so it's a good match. Radio is happy. Radio is happy, but I mean, all antennas need, if you think of them as a dipole, where would the other half of this dipole be? Theoretically, if you were doing this properly, even though these are advertised as not needing a ground or not needing a counterpoise, you should do this. Because the other half of the antenna, the RF has to go somewhere. And if you think of it as a dipole, the ground... See, this is where I start waffling because it gets kind of complicated if you're talking about dipoles and verticals and where the other half of the antenna is. But think there's always another half of the antenna. And if you don't have a ground or counterpoises or radials or whatever, then where's the RF on... Where's the other part of the antenna? Oops, I just removed my trunk of the tree. Where's the rest of the RF going to go? Down the coax. So, again, this is meant to be a simple antenna. You don't want to be thinking about, am I digging up my garden? Am I putting out radials? Once you've got an earth like this, then there's other things to think about as well, like separating it from the earth from the house, just in case you have a fault and a broken earth in the house. Where's your earth current flowing? Is it down to the ground via the antenna path? But I'll stop myself again because I keep doing this. So, as you've got your license, you have what is perceived as a reasonably low power limit, say 5 watts. You need to make sure that your 5 watts is radiated. And looking at these antennas, if you have an efficient antenna with 5 watts, you're probably emitting about as much RF as a multiband compromise antenna with probably 50 watts. So you'll notice I'm emitting an ATU here, and I'm doing that for a reason. And again, this is a mistake many people make, is like, I want to operate all bands. I'm new to radio. I'm excited. I don't want single band. I'll throw a bit of wire up. I'll put up a dipole or anything, and I'll just stick an ATU here. This is my ATU. So we have coax, ATU, coax, to something. Doesn't really matter what. And instantly you have a huge mismatch between the impedance here and here. So it's just loss. You have radio coax, you have ATU loss, you have coax loss, you have an inefficient non-resonant antenna loss. Do you see why people might be struggling with foundation license, power limits, those wanting to work QRP? In fact, anyone. It's amazing how many people can dump 100 watts into an antenna and barely be heard. So don't do this. You have two, if you want to make the most of your RF, you have two basic antennas. Again, I'm not getting into balanced feed and things like that. First of all, we're back to the antenna we started with. This is perhaps the simplest, most efficient antenna you will find. It is a dipole. So you have the ends here, suspended in your backyard or garden. Maybe some trees, ideally. My crude drawing. Now, this is balanced. It doesn't require a ground. Both parts of the antenna are in the sky. So by balanced, and this again, balun, I can't emphasize how important this is. So both halves of the antenna are in the sky. You don't have to worry about ground or earth. It's because it's balanced and you have a balun. You don't get RF on the coax. You also don't receive RF on the coax. So it's, by design, a very quiet antenna. So, yes, it's kind of single band, but it isn't necessarily. Now, if we say that this is an 80-meter dipole, I won't go into details here, but resonant harmonic frequencies are then 40 meters and 20 meters. Now, whilst you'll see, if you plot the SWR graph of this antenna, say that's 80, 40, 20, I should just make that clear. What you'll see is something like this. You'll have dips. I mean, that's not very good. It's probably more like this. You'll have dips in SWR. The antenna is cut for 80 meters. So this is an acceptable SWR around here maybe. And that is lower because it's cut for the band. So you'll see these dips, and theoretically you'd think it would work on these, but due to other reasons, the first harmonic is a no-go. It's not efficient, even though you get a dip in the curve of SWR measurements. It's not efficient on that frequency. So that's the fundamental first, second. So I can't remember whether we're calling these odds or evens, but on every other, it's a no-go. So you have 80, 40, 20, and up here you would theoretically, not 30 megahertz, 10. So you may be lucky and get a match here. Now, this is where an ATU could come in useful, because it's near enough. You're only just pulling it into an acceptable SWR for the radio. Now, if you had an old-fashioned tube, vacuum tube, valve, whatever you want to call it, radio, this would be less of a problem. But because of modern radios, this is the only time I would use an ATU, is if you wanted to try and get a resonant harmonic frequency on the dipole. So yes, you could put an ATU here, but this is not to rely on for general use. This is just take this into a more manageable level for the radio. But perhaps that's already slightly overcomplicating things. We're talking about efficiency, and we've just put an ATU in, and we've got not a particularly good match, so we're introducing inefficiency. What else can we do? Well, we can do this. Oops. We have another element, a shorter element, and we have string or whatever rope here supporting it, fishing line. So then we have 80 element here. Maybe we have a 40 meter element here. Now these may slightly interact, so they might not need to be just adjusted slightly in length, but this is a fan dipole. And there's nothing to say that we can't have more. In fact, there's no limit apart from physical limitations of space. You could have 20 elements, 20 meter, and if we pretend we're looking down on this, so let's remove the trees. The trees are now here. Our radio's still here. So this is looking down from a bird's eye view. There's nothing to say that we can't put our elements like this. So these are perhaps 80. These are maybe 40. Maybe this would be 17. So they're going horizontal, like this, across. So if your garden is here, you have this strung up somehow, as long as it's high enough to not garrot people that walk underneath it. It's quite flexible. And this, again, there's no ATU. All of these are cut, so they're resonant. So your power goes in, your power is radiated. There's very little loss involved, apart from the loss that comes from the coax, but you can spend more on coax and reduce your loss. Now, if you don't have space for a dipole, then your other option is a simple vertical. You don't need a balun here because it's unbalanced by design. I'll put an earth symbol in here. So the inner of your coax goes up a quarter wave. Again, we're keeping things simple. And down here you have earth. Earth spikes, probably, realistically, we're actually talking counterpoises. Either on the ground or ideally below the ground. And these, we can discuss counterpoise lengths and depending on where they are and how if they're buried or not, but just for ease of use, ease of discussion, quarter wave. And we probably have about 8 is a good number to start with. More is better. You can get away with less. But let's start with about 8. Efficient. You shouldn't, if you've got enough counterpoise here, you shouldn't get any RF coming back. If you do get RF coming back, it means that your counterpoise network is not good. Maybe your soil is not very conductive. Maybe you don't have enough of these. Something you need to look at. But again, this is a simple antenna. Now, if you've got a mast, let's put a mast up with a kind of horizontal top bit. You can do this. One element tied up with a bit of string. shorter element tied up again, 40-meter element, 20-meter element. Think of this as a fan dipole, but it's only one half, so you have the multiple lengths. And do you know what the most frustrating thing is? These antennas are really efficient. They work really well. There's no loss, there's no ATU. You can make them multiband antennas by adding multiple elements. The frustrating thing is, if you go on eBay or one of the shops that are targeting new operators and you buy one of these long wire baluns, and you spend 60 or 80 pounds, dollars, euros, for some compromise, you then need to buy an ATU to match it, I expect, or you have one of these off-center-fed dipoles, and because of the balun involved, you need to spend more money again for a compromise antenna. You know, they do work. I have to say they do work, but they're problematic and they're less efficient. How much does it... We go back to our dipole. The only thing here is the cost of the balun, which you can get a reasonable balun fairly cheap. If you're talking QRP powers, you can get one very cheap. But if we're saying we get one that can handle full license, or at least 100 watts for future proofing, you're probably talking 30, 40 pounds or euros. And then wire is cheap. It's a cheap antenna. It's a cheap, efficient, resonant antenna. You can't really get better than that. I mean, with a vertical, get a fishing pole. I don't know what we call them. Like the fiberglass supports, you can buy them really cheap for £5 or £10, euros. You can get these 5 or 7 meter poles that you pull apart and turn them so they... the big fiberglass pole. So run a wire up one of these. The pole is £10. You can buy them cheaper from China if you want to. Wire is cheap. Radials, wire is cheap. You can start off, just hammer a piece of wood in the garden. I mean, I've done this. I dug a hole, put some wood in, put some rocks around the wood, filled up the soil around it. It's not permanent. But you then tie the fishing pole to the stake in the ground. You got your 5 or 7 meter high vertical bit of wire. These are cheap antennas, and they don't require any technical expertise. The only thing you need to do is cut this to size. And this can, put the antenna up, try it, it's slightly out, cut it, or fold it back on itself, ideally, so you can undo what you've done if you've gone the wrong way. Put it back up, test it, take it back down, adjust it again. But in doing so, you get a match of about just above, 1-to-1. Again, it's an efficient, cheap antenna. So I can understand the attraction. You're new to the hobby. You just want to spend money and get something that ticks all the boxes. It does all the bands you want, and magic, no thought required, throw it up. Simple to erect, get on the air. But really, the amount of frustration you'll likely suffer from RFI, from not being heard, from noise, increased noise floor. Honestly, stick with something simple. Simple, as I said at the beginning, generally is more efficient. The more compromises you have in an antenna, the less efficient it will be. And I'm hoping I've done this a bit more clearly than I did yesterday when I was getting into more theory. So, yeah, thank you. That's it for now. If I think of anything else while I'm putting this video together, I'll just tack it on to the end, because I'm sure there's probably bits I've forgotten. The only thing I will say is, talking about baluns, you'll get a lot of people online saying, I've never used a balun, I've never had a problem, it's a load of rubbish, it's unnecessary, a waste of money. So we're back to this, back to our dipole. And I was saying it increases the noise floor from your computers, from mobile phone chargers, it causes more RFI, causes, interference. You can trigger security lights, there's all of this. If you don't have a balun and these people are saying, I've never had a balun, then you have nothing to compare it to. If you start with a balun, then you'll have, if you later want to omit it, see, why not? Try it, experiment, see what problems you get if you omit this. Try different antennas, try your long wire, try your off-center-fed dipole. All of this can be experimented with. If you want to try and create a multiband antenna, knock yourself out. But by starting with something like a dipole or a quarter wave vertical, perhaps, you have a basic, efficient, fantastically performing antenna with which to compare these. If you don't have a basis to compare things, then anything will seem good. I can hear people, people can hear me. But there's a big difference between, 3 dBs is what, half an S point, or 6 dBs. You can still have significant loss on your system and still hear people. What's the difference between someone at S9 and S7? Not great. You can still hear them very well in terms of fidelity. There's not a huge difference. But try working someone at S1 and then find that you've got 12 dB loss or something in your system. You won't hear them at all. So you don't know what you're missing if you don't have a good basic antenna to compare it against. So yeah, slight bit of a rant, I apologize, but please do things properly and simply, and then you'll be in a really good place to further experiment and compare your results in the future. Thank you. I hope that was useful. 73s from OH3 SPN.